requirements, or you get requirements but they're missing key characteristics like performance and reliability, and then you have some issues with that. We forgot to think about this. Now, the interesting thing about requirements is they're the obvious benefits of having good requirements, good testable requirements, but we've also seen cases where the benefits were things that you wouldn't even expect, and I'll show you an example of that in a minute. And we've seen cases, on the other hand, where bad requirements ended up being a source of a lot of unexpected grief. So, I think it's fair to say, if you understand the requirements, you can build quality, and conversely, if you don't, then you can't. Because how would we build something that was fit for use, fit for purpose, one of the definitions of quality, if we didn't know what it was going to be used for? Right? I also want to point out something, and for those of you who are working on projects that are applying Agile methodologies, nowhere in the Agile Manifesto does it say no specified requirements. It does not say that. What it says is that they value running software over detailed specifications. See the difference there? That's not the same as saying don't bother to write anything down. And we see a lot of this with clients that are trying to apply Agile, is they take this black and white interpretation of the Agile Manifesto, and one of the things that they say is, oh, we don't have to write anything down. No. What they're saying is, only write down what you need to write down. So that does not excuse project teams from writing down requirements. Okay, so let me give you an example. Case study. Long-term costs of bad requirements. We have a client. They're good people, they are smart people. And I want to point this out. All the case studies of problems that I'm going to talk about, don't just assume, well, that couldn't happen to us because we're smarter than that. Every one of these case studies of a problem, these people were smart, but they made a mistake. This particular company, medical software company, had very vague requirements. There were a lot of gaps. There were a lot of things that weren't specified. A lot of testability problems, and they didn't manage them well. They get a phone call from their customer in the middle of the project. Oh, you know that the requirement we had for this, that, and the other thing? We want to change that now. We want to make that a little different. And the person would just go in and modify the Word document. No change tracking. Send it to the programmers. Hey, here's your requirements. Okay. Maybe people get a little confused. Yeah, people get confused, developers get confused, and so surprise, surprise, the code isn't very good. Now, what they found after the fact was there were a lot of data quality problems. Okay, this program is managing safety critical data related to medical systems. Would it be bad if we had corruption of the data related to people's response to drugs or something like that? Yeah, that would be bad. And so now they found this out. Oh my God, big panic. They've now spent over $100,000 trying to fix the problem, and more to come. Now they've learned the lesson. They are writing better requirements. It's better to learn the lesson late than never. But, it's a near miss, a near-death experience for the company to go through this. Now, another client. This is a case study of success. They're also in the safety critical systems business. They have really good requirements, and the requirements are documented in a machine-readable way. And my associates and I were working with them, and we realized, hey, this is great. You get testable requirements, well integrated with your FDA, the Food and Drug Administration, which is how medical systems are regulated in the United States. They have requirements for traceability between their tests and the results and the requirements. So they didn't have any problems with that. But here's the unexpected benefit. We found out, requirements are machine readable. So we designed and created this test tool that could go through and based on reading the requirements, the tool reading the requirements, it could automatically traverse through the screens and verify that the right things were happening, and verify that there weren't reliability problems, the screens were correct, and then, oh, by the way, they can figure out how to make it do localization testing for them too. They can check that the screens have been properly localized for the dozens of different languages. The benefits have just kept coming and coming and coming. If you're curious about this, there's this article called Quality Goes Bananas, and don't blame me for the title, it was picked by the editor of Software Testing Performance magazine. But it describes how this tool works. Now the great thing about this tool is it was built in about 4 weeks, total tool budget of $0. Downloaded free stuff off the internet. Okay. So, who would have thought, right? You had good machine-readable requirements, and all of a sudden you were able to do all sorts of reliability and localization and screen flow testing for free. 4 weeks of work. Okay, so another lesson. Don't wait to the end. Don't wait to the end to get serious about quality risks. This happens over and over again. But there are a lot of times when it's very clear during requirements and design that you have risks to the quality of the system. Bad things that could happen that can make your system not satisfy your customers, users, and other stakeholders. That's a quality risk. It could be performance related, it could be reliability related, it could be functional, but many times these things are clear early on in the project. It's clear oftentimes during design. Hey, guess what? We've got complex interfaces. There's a lot of things that could go wrong here. Now, do we want to wait? Probably don't, but many times we do. And this is too bad because you can use models of various kinds, simulations, for example, to identify and remove quality risk during the design period, rather than waiting. You can do component integration and system testing, rather than just waiting, oh, well, let's scrub all the bugs out at the end. A lot of times we've seen with clients that you get into situations where you've got this big tsunami of bugs coming at you at the end, you can't fix that. You can't undo the design problems that were introduced earlier at that point. So, example, bad example, failed project. This is really sad because this didn't have to happen. This is a 2-year-long project. In the beginning of that project, one of the senior members of the technical staff built a simple spreadsheet, Excel spreadsheet, that predicted various kinds of performance problems that would happen with the software running on this large, complex server. His predictions were amazing. Resource saturation at exactly the point where he said would happen, all that. They had this spreadsheet, he showed it around to people, and they said, oh yeah, that's bad, we should probably deal with that, and then they didn't. Okay. Design, implementation, component testing, no follow-up on this. Nobody checking to see, are we having the problems that were predicted in that spreadsheet? We get into integration test, system test, big problems. Big server performance problems. So, he said, oh, let's start patching. Let's start patching problems. So, here's the performance on the first run of the performance test. You see this is the response time, that's the desired upper bound, and this is the legal supported load. So the response time should have been no more than that. This level of load, but we can see kind of a problem here. There's the bottleneck happening, right? And then, oh, okay, well let's patch it. Let's throw some hardware at it. Let's do some